on the second lesson course with 08350 as the course code. And today we have the relatively leisurely start where I tell you what the idea is that you do. And then you see all that happening. You start a little bit with some things that you actually have to do. Today is all relatively easy and straightforward. However, there is one thing that I typically ask, and that is that you close your laptop. The reason is simply that I find it annoying if you're doing something else when I'm talking here. And it's critical, there's no reason. So everybody with a laptop open, please close it, send it to your phone. You will look at your laptop fine, but then do it somewhere outside. There too. And the girl there too. What's up? Stop up. Right and keep it there. Okay. So, the program for today, I'll take you through what a typical week will look like. And then tell you a little bit about what we're up to in general. What it is that we need to do to pass the course. In principle, the good news is to pass the course is relatively easy in terms of what it is that you need to do. The tough part is making sure that you actually do it. We'll get back to that in a minute. Then, as you may have noticed, the whole course is on Canvas and not on Oase, or also not on home course or Moodle or where have you. So all the stuff that I will put online you can find there. I'll talk a little bit about the data and a little bit about the statistical vehicle that we will use, and there is a program called Stata, and also why we use that and not something else. That will pretty much wrap it all up, and then the rest of the afternoon you could use to make sure that you're all set up to do all this kind of thing. Okay, so this is the, let's say, general aim of the course. At the exam at the end, the following will happen. You get data looks like this, sort of like a big spreadsheet, and then you have to do something with it. This is a view that makes sense. So, in principle, that is what I'm up to. At the end of the course, I should be able to give you some data, and you should then be able to do something with it that makes as much sense as possible. So that's the whole aim, and we'll take quite a run up before we actually get there. Starting from, okay, how do we deal with data like this for, let's say, relatively small scale problems, making it more complicated along the way, and in the end, it should be good to go. Two examples of the stuff that we should be up to in principle. One is relatively well known, a couple of years old. This is the world famous Netflix example. Before Netflix was what it is today, and now it is a place where you can rent your movies streamed, so you get the stuff streamed to you, and there are no tangible DVDs anymore anywhere in the world with Netflix. Actually, that used to be the case. Not so long ago, the setup was that you rent an actual DVD, and as soon as you're done, you mail it back to Netflix, and they send you the next one on your list. So there was tangible DVD stuff out there. And what they, of course, wanted was that they can predict quite well what it is that you like, so that if you have nothing in your list of movies that you want to see, that they can suggest you an actual movie, and a movie that you're happy with, in the hope that you will continue paying to Netflix. Easy. And given that everything is online now, that problem still remains, because do you have any Netflix people here who has paid service, just like me? Quite a few. You get a gazillion suggestions to you along different lines, for instance, of the kind, you watch this, and given that you think you might like something else. Or if you're into something that is typically new on Netflix, then watch these. So what they wanted was the following thing. They already had a recommendation system that said, okay, if you like these movies that you've rented with us, or that you have at least just evaluated, then we have a pretty good clue about what it is that you like elsewhere in our set of DVDs. And the suggestion was, if I remember correctly, you can rate movies from 1 star to 5 stars. And the algorithm that we had was correct, plus or minus, I think, 0.7 of a star. So there was a bit of margin there, but already quite good. And what they suggested was, well, try to improve this in such a way that we get 10% better. So let's say, loosely speaking, from 0.7 to 0.6. And if you get that, you get it right. As soon as you have that, you post it to us. At that point, the whole contest ends, or actually not completely. At that point, the contest will continue for another month. Every other contender can then submit whatever it is that he or she has, and who is best after that month is the winner of $1 million. And that worked quite well, especially in the beginning, where you could follow your own progress. You've got some data to work with, and then you could see how well you were doing. And pretty fast, within 2 or 3 months or so, you had people who had, from the 10% that needed to be covered, roughly, let's say, 70% of that part done. So it looked like, a couple more weeks, and then we were actually there. It turned out to be way longer than that. And what people did was, show that one. You have leaderboards in between where you can see how well or how poorly you are doing. And at some point, it had to stop. Here you see the ones who actually won. They had the 10% increase just above, and a couple more were actually quite close. They had some way of calculating how well or how poorly you were doing. And in fact, if you would participate here, you had 2 gigabytes of data to work with to try to come up with a decent prediction. So what they had was stuff behind. This is why I want to go here. Okay, what we know from you is here on the left. We know how often you have rented, and you know what kind of things you have rented, which might be useful. If you like something part 1 and something part 2, something part 3 might be a good suggestion. So it's useful to have an idea there. How often you rent, when you rent, that also might make a difference. If you typically rent on a weekday and they somehow figure out that you are alone, that suggests already something about the kinds of movies you're more likely to rent. In the weekend, when you are with your boyfriend or girlfriend, it's perhaps more likely that you rent something romantic rather than the action movie that the guys wanted to rent. So knowing which day of the week it is also useful. And in the end, you want some output, for instance, the number of stars, a suggestion as to how much you like that actual movie. So that is what the people here are aiming for. Okay, at some point it was done. I think this is even a subset of the whole team, because in the end, a huge team with all kinds of computer geniuses actually won the whole thing. The $1 million for them was, I think, relatively poorly paid for all the time that they put in and all the smart heads that were investing time in that. But in any case, it gained a lot of attention for Netflix, so for them it worked very well. And in fact, the algorithm that they came up with, which was better than the one that was there, was so complicated that in the end it wasn't even implemented. So the stuff that you now get from Netflix is, well, perhaps related to that, but certainly not the one that they came up with. And in fact, it went so well that there was a Netflix Prime 2, where the aim was slightly different. Because something weird happened in the sense that if you looked at the list of teams who did very well, let's say the top 50 or so, and you would take the 10 last ones from that list, so the numbers 41 through 50, and you average out their predictions, then they would end up somewhere in the top 10. And nobody had any clue why that would be. There was a general sense that something must be going on because these guys here too, what they did was they created not one model, but I think 120 or so different predictions that they averaged out. So averaging out a lot of predictions seems to be a good idea. Netflix was interested in that, but at some point somebody suggested, yeah, I don't like from the outside, I don't like this at all, because in principle, perhaps you can find back who I am in the Netflix data. This is invading my privacy, and they got their way in Netflix and stopped. So they started with the second Netflix 2. It was, I don't know, on for a month or so, and then it's all stopped. Okay, but in principle, these kind of things, you get a lot of data. Well, we won't use 2 gigabytes, but you get a lot of predictive variables to work with, and you want something that you need to predict in the data. That's also something that we're going to do, and of that kind, there is a lot online, for instance, here at Kaggle. Becoming more and more standard. If you are a business and you know that you have data and that you want something with the data predicted, but way to make sure that it happens is you open up your data to a casual contest. Teams or individuals can actually try to come up with a good prediction. For instance, here forecasting of tourism numbers. Lots and lots of people compete for, well, sometimes even relatively small prizes. So 5,000 or a couple thousand or even a couple hundred even might be the only thing that you need to invest. Of course, you have to somehow figure out that the data you put there are not invading the privacy of your own customers. And that tends to work very well. And in fact, just to show you that in principle, this is the stuff that at the end of the course, if you're doing well, you should be up to. 1 year we actually tried to compete in something like this, and then ranked in the end 19th out of 51, where we were competing against, you know, the University of Computer Science somewhere, so people who know this probably better than we do, but nevertheless we did quite well there. And the sort of, I must admit, is because if you would look up the actual list of scores there, then you won't find us in the ranking. This is because the one student that was responsible for actually submitting our predictions did it slightly too late. So okay. But we, in the end, checked, and we would have ranked 19 if we would have submitted on time. Okay, so that's one part, a big bunch of data, or a small bunch, and you want to predict with a set of predictor variables something on the right side of the model. It need not be like this. I'm not sure if Daniel did the same experiment here with you that I know that he did before in the introduction to psychology course. This is the experiment where you use your smartphone to measure your heart rate, and you check if it makes a difference if you are not thinking about anything particular versus if you're thinking about a memory where you were very angry or very happy. Everybody got that in the introduction course as well? Who didn't? Okay, so the setup was, in brief, I think exactly that. I don't remember I have all the details by it, but I think these are 3 measurements on the same person with a smartphone. With a smartphone, we're measuring heart rate first when you don't think of anything particular. Then you're asked, think about a case where you were really, really angry, relive that moment. Now again, with the smartphone, you measure your heart rate. And the third condition was, now think about a time where you were really, really happy, and then we measure the heart rate. And one of the aims here would be to check, is it really the case that in the control condition, the heart rate is lower than in both of these other conditions. And one of the aims in general is, of course, it's possible to measure your heart rate relatively decent with an actual smartphone. Turned out to be the case. But the big point here is, well, this is also something that you need to do with data. Here, the big aim is not so much that you want to predict something. It's not that, you know, if I know that you're now thinking about something where you were angry, I want to predict that your heart rate is 82. That's not the point. The only point is that there's a difference between the columns over here. So these over there should in general be lower than those over there. And the same goes for the happy sign. If I remember correctly, in the end, this also turned out to be the case. So these numbers there were actually, I think, both higher than those. And I think that the angry memory was the one actually that led to the highest heart rate. But in any case, the big thing to get from this is, well, if you do this, typically the data set is much smaller, and what you need to know here is not so much a very, very accurate prediction. Nobody cares about that, but you only want to know is there a difference between these two conditions, or 3 conditions. Okay, that is in fact lesson number 1 that will, I hope, sound relatively obvious at this point, and will start to get a little bit more troublesome as we proceed. There are all kinds of things in the models that we're going to see that measure something of the kind, how well does the model fit? And it might very well happen that it turns out to be that quite a few of these models do not fit very well. The thing you need to realize here is that the fit of a model only plays a role if you're interested in the prediction part. We're aiming at, I want to know very precisely if you like the actual movie, or very precisely, you know, what the weather is going to be tomorrow, or what the stock market is going to be like tomorrow. Then all these things make sense, and later when we are used to Stata, you'll see that Stata will spit out all kinds of summary statistics about whether or not a model is good, and you can basically disregard a lot of that if you are in a position where the thing that you want to know is not predicting very well, understanding very well, as in the case with the actual hardware. Okay, so that was one thing to get off my chest. Back to the course setup. We will go through the Stata book that you see here, A Gentle Introduction to Stata. I think the 4th edition, yeah, is the one that is the most recent. If you happen to have one that was before that, then I think you can actually get away with it. So that could work. Besides this, you'll see a couple of people very happy about the fact that we somehow got a hand at the older book. Besides this, there are a lot of other material online. I will go through the book without mentioning it very often, and you'll see that there are typically chapters that go with the separate parts of the lectures, and online there is additional material, first about what it is that you need to read in the book that went with the lecture, and second, what else that you need to read if there is stuff that is not in the book. Okay, let's see. Yeah, for those who are late with the book, I put chapters 4 and 5 online. 1, 2, and 3 you really do not need so much. This is sort of, how do you start up Stata? Yeah, just click a button somewhere, so you don't need a whole chapter for that. In 4 and 5, the first real stuff starts, and for the ones who are late, I put these 2 online. Okay, then video lectures. There is no official video lecture here, but what I typically do is I am recording my screen here and the sound, so that will be available afterwards as a screencast. But it is sort of an extra and nothing more than that. So what might happen is that my computer blows and somehow I don't get an actual screencast, tough luck, or something else goes wrong that might happen. And then, nothing that I can do about it at that point anymore. So if you want to be sure that you've heard everything, then make sure that you're here. Otherwise, try to use the actual screencasts, and very often that will actually work, but every once in a while we might miss a few. Oh yeah, and one other thing, that there is, as a general but sort of unspecified rule, if attendance drops below an unspecified number, I'm going to quit the screencast. If I'm standing here all by myself, it's not so. It's not a nice thing to do. But for now, we'll keep it like this. Okay, then your typical week would be Wednesdays. That's today, hour 5 and 6. I'll lecture for 2 hours. Then there are 2 hours left, where you can actually go on with the assignments that are online, or the wikis that are online, for you to work with. The easiest thing to do would be to stay here in the room. I will stay here in the room as long as there are people here. And for all the stuff that you need to practice, there is somebody else there then to help you out. But all up to you. And on Fridays, hours 3 and 4, there is a lecture as well. So that's the general setup. 4 lecture hours, and in principle 2, say, working hours where I'm available for assistance if you need it. Software, then. I think most of you are not familiar with Stata, besides the ones who have taken the course earlier, and perhaps are familiar with SPSS and certainly with Excel. All the software that is, say, statistical in nature has basically the same kind of setup. Behind the scenes, it's a spreadsheet, and it can do lots of things in easier ways than an actual spreadsheet can. In this case, we'll use Stata in flavor 14. There are a couple of reasons why I personally prefer Stata to SPSS. The easiest way to say that would be, I think it's just a better program, but that needs a couple of arguments, I think. First, I think that the user base that Stata has is way bigger than SPSS in the sense that you can benefit from it. So if there's something particular that you want or want to find, then there is quite an active user base and user forum where you can find all kinds of assistance that'll help. The whole program is a little bit more stable than SPSS tends to be. I haven't checked for a couple of versions of SPSS, so perhaps they became better. Then also I think that in general, trying to stick to the same program all the time is not necessarily a good idea, because for you as well, by the time you go out in the world, so to speak, then who knows, Theta might not be there anymore, and you have to use R or something totally different. The main thing would be that you're not scared of what's about to happen. It's again a spreadsheet with something on top of it. So being able to switch easily should be relatively easy. Yeah, one thing that I'd like to bring home quite seriously is that you need to work with syntax files. That's perhaps not something that you're used to. So quite a few of these programs have a Windows interface. Stata also has a Windows interface, so you can click around and do something. I think in general with data analysis this is not a good idea. What you want is, okay, this is my raw data, the data that I get, and here I have a set of commands that I execute on the raw data. So that in the end, if I have the same raw data that you have, and you send me your syntax file, I can simply execute that syntax file on the data, and all will work. Also at the exam, if that's, let's say, more convincing, if you find out at some point that you made a mistake somewhere in the beginning, this is still easy to repair if you are in a syntax file. It's impossible to repair if you just executed 20,000 different clicks one after the other. And you also don't remember yourself what exactly it was. So that syntax file stuff we need to get used to. And I think that for many commands, you see that down the course, there are actual commands in Stata for stuff that you need to evaluate only visually in SPSS. So for all kinds of things, you have plots that might help you. So look at the plot. If everything's all right, this plot should look like a normal distribution, or this plot should look like noise. It's not so easy to evaluate, for instance, if a plot looks like noise. Might be that it looks like noise to you, but not to me. So it would be better if you have actual tests for that. In Stata, quite a few of these tests are available. Okay, then Canvas. Canvas is the new on-course, or the new OAS, the new everything. We're migrating with the whole university to Canvas in the next 1.5 years or so, and we started already. If you're used to on-course, it's not so different. It's basically the same kind of learning management environment that you're used to, only the colors look slightly different. The rest is pretty much the same. Let's see. Yeah, and you're in principle enrolled automatically. So there's nothing that you need to do for that. If not, then contact me during the break, then something has gone wrong at this point. I will try to sort it out. Okay, this is what it looks like. One disadvantage if you're into more visually pleasing material, no pictures here that we can easily put up, at least as far as I know. Perhaps I'll find a way to do it. So it will look like a long list of different, these kind of things are called modules. So this is a module here, course info and study guide. Starting up Stata as a module, descriptive statistics and graphs for one variable as a module, and there are in fact already more modules down the line. And we simply follow all these separate modules. Let's see. For all these, we have roughly the same kind of setup. All modules have a forum. Actually, they're not called forums in Canvas, they're called discussions. So if you have any kind of question about that actual module, make sure that you ask it in the discussion forum. And don't send me an email about this, but put it there. I keep track of that. If I know the answer, I'll give it. If you happen to know an answer, make sure that you give it as well. There is a little bit about what you need to do in the book, which chapters it is that you need to read. I also try to make sure that I give references to online material where basically the same things are being explained as well. So if for some reason I screw up the explanation, or you don't get it, at least you could try with somebody else who tried to make the same point differently. Then we'll have, let's see, assignments. The book itself has in different chapters also assignments that go with it. There's no need to do each and every one of them, and typically I'll show you there which of these assignments I think are the most useful. And finally, here the last one, we have wikis, which is in terms of Canvas basically a page where the page can be edited by not only by me but also by you. This is a typical assignment of the kind that you get in the end at the exam. So there, what you'll find is an assignment. Okay, here is some data and check this or that. And the answer there you should supply yourself. And I won't interfere with that at all. And if you want to make sure that in the end you have for all the wikis, because there are going to be many, many different wikis and all these different modules, if you want to have the answers for sure, there's only one thing to do. You go to the wiki and you complete it as good as you can. If you think it's done, let me know. Send me an email, or send me a forum post, fine as well. I think this wiki is done as it is. If I get an email like that, I check the wiki. If it is, I sort of wrap it up and brush off the things that are not exactly right, and then I close it, and then you have the right answers right there. So, you know, if you all do part of these wikis, then at the end you should have all the answers complete. The only sort of dangerous thing that can happen is that everybody thinks, okay, I'll wait until somebody else does it, and if we wait long enough, he will do it. Okay, he won't. So already now I can tell you, if nobody sends me an email about, okay, I tried this already, I think it's done, and now have a look, then we have nothing. Okay, so this is basically up to you to complete. If you find the time to do it, then we should all be good to go. But if you don't and nobody does, then we have nothing at the end. In principle, all the wiki assignments together is what you should be able to do for the exam. Okay, so let's see if I cover everything here. First, yeah, check that you're enrolled, of course. Then, if you're interested in preparing or working ahead, well, you can see the modules already right now. We'll simply go one by one from top to bottom. So that's the actual order of the different modules. Yeah, also do realize I try to supply, let's say, a little bit more material than is actually necessary. So it's not strictly necessary that you do everything there, as long as you can follow what it is that I'm doing in the lectures. And follow what is in the actual assignments, where it's specifically said that this is something that you need to know, then you should be fine. I mentioned already that the answer to wikis will not be supplied online, at least not if nobody does anything. Let's see. Yeah, the answer to the assignments, those I can supply if need be. Quite a few of these assignments are relatively close to the actual examples in the chapter. So, you know, I'm exaggerating a little bit, but if the idea would be, we have a summary command. If you type the summary command, then you get a summary of a variable, and then you have an assignment there. Yeah, type the summary command and get the summary of the variable. I can assume that you know how to do that. So these I won't supply, but if there are a couple there where you have no clue what to do or tried it and it didn't work, just let me know and I'll show you what I think it should have been. Yeah, then for all kinds of stuff, make sure that you use these forums. I try not to answer emails if they have questions that can easily be put on the forum. It's simply easier for everybody if I don't have to answer the same question 20 times. If it's over there, then everybody can see it better for everybody at the same time as well. Also, yeah, have a look around. I'm not exactly sure myself at this moment what kind of possibilities there are in Canvas. Maybe all kinds of interesting stuff. I saw that there is a chat available that was actually used, for instance, because in the link to the survey that I sent, there was a typo. I left a comma way at the end, and somebody in the chat talked about that. So that is a useful thing to check. Okay, then, passing the course. There is a professional skill involved with the course as well. The date for that is somewhere way at the end of the actual course, and I don't know exactly what it is at this point, but just so you know, there will be a professional skill at the end of the course, and it's a mandatory part to be able to complete it. Then, there's something else that is mandatory, but that won't give you an actual grade, is there are 2 quizzes during the course as well, where the only thing that I will ask of you is simply that you do them. And you will get back how many you had correct and how many you had wrong. But there is no official grade for that. So just to make sure that you are busy with the material, that's all. Then something else, you have to make sure that you access all parts. Yes?
Are the quizzes done by clickers or?
No. Online. You have to make sure that you access all the parts of the different modules. This is something that can be relatively easily checked by the system itself. The only thing that is a bit of a nuisance for you is that you cannot see if you've clicked everything in an actual module. You have to make sure that you open all these and at least take note of what was there. And that we check if you do it. The last mandatory, but not for a grade kind of thing, is filling out the survey. Quite a few things that we'll do that will have to need a little bit of data. And I started sending out URLs to an actual survey. These data we're going to use as soon as we do something with actual data. By now I think I have 120 or so of the 180 complete. If you haven't done this just yet, make sure that you complete it by today. That gives me a little bit of time to prepare the data and hand it over to everybody else. Okay, then, now we get to the grading part. 2 in-between tests that do count. One on December 7th and one on December 31st. Not my favorite dates. The first one not so bad in the neighborhood of Sinterklaas, but the second one quite close to Christmas. It's the only date that I could get where we actually have a room to make sure that it will work. So these are 2 intermittent tests where largely you'll get multiple choice questions. And for these you get an actual grade. The grade counts together for 30% of your grade for the whole thing. Yeah.
So we need to be present there.
Sorry?
So we need to be present on the test.
Yeah, you need to be present live in an actual room where, yeah, it's not something you can do from home or. Yeah, exactly. Yes.
Test done on laptop or not?
Yes, that's the one.
So why can't I do the test in my own country?
Because I have to be sure that it's you taking the test. Yeah, which is, let's see. Anything else about the in-between tests? Yes?
That one is not bringing your laptop, right?
Sorry?
For that one, you don't have to bring your laptop, right?
Yes, so that one you need to bring your laptop too, for sure. Yeah. Yeah, we'll go through the details of the test when it is closer to December 7th. That should be all. At the end, there is a final exam counting for 70%, and the difficult part of that is that whereas the intermittent tests are largely, let's say, multiple choice, a couple of, let's say, small answer questions, it could be that you are, let's say, good enough to complete the intermittent test in a multiple choice kind of way. So if you see the right answer from 4, you're able to do it, which might not be the same as if I give you data to do it, that you know what to do at that point. And at the exam, that is the skill that you need. This is why these wikis are there. You get some data, do something with it, and the risk is that you might do quite decently on the multiple choice part, but then in the end, you find out that with actual data, it's not so easy anymore. So this is something that I at least want to warn about up front. Yeah. Let's see. Okay, passing, you need a 5.5, and I think that Bachelor College rules suggest that you need for the final exam at least a 5. Even if, let's say, a 4, together with the 9 that you have for the intermittent test, would in fact be good enough, but then still you have to retake the exam at the end. That's pretty much it. Okay, so let's see. Yeah. Oh yeah, this is always an interesting part. Now we get to the part where I have to explain, to my own dismay, that at the final exam, you need to take it on a laptop that you bring and that runs Windows natively. The problem is that there is no other way to be able to check what it is that you're doing, at least as far as I know now, than to install some software that we have for Windows, but not for Mac or Linux or whatever other operating system you might have. So start already making preparations for the fact that by the time that you need that final exam, then you need an actual laptop running Windows. Also also no running Windows in VirtualBox or in VMware or something because it's easy to get out of that.
For the interim test, do we need like laptop with native Windows 2?
I'm still checking how easy it would be to close all that up. You know, many more people are now, of course, using Canvas, and the university is trying to figure out a system where it's easier to, for instance, close the browser. Not close the browser. You can open the browser, but nothing else. The rest is then closed. I'm not sure if they have all that set up by the time that it is December 7th. So it might be, if not, that we have to do that Windows on laptop on December 7th already. But you know, I'll let you know soon. Other questions about this? No? Okay. Yeah, this is sort of a, well, do-it-yourself course is not really the word, but it is the case that, you know, I'm talking here and explaining as much as I can. I will be here on hours 7 and 8 helping you through the whole stuff, but the essential thing to do is basically go through all that material yourself. If you do this on a weekly basis, you should be perfectly fine, but then still, you need to discipline yourself to make sure that you actually do it. I don't want to run a clicker test every week or who knows what. First of all, I think that in general the clicker test with larger groups is basically a zoo. So I'm not so sure that that is going to help. And I also think that in principle, yeah, you're responsible to make sure that you do all these kind of things. All grown-ups should be good. Okay, yeah, then one last slide in which I try to make the point that it's really a good idea to not to choose the strategy where you do nothing for the first part of the course, then wake up 3 weeks for the exam, and then do it all together. Typically that won't work. Quite a few people have tried, and also quite a few have failed. And in a way, the worst thing that can happen is that you pass and then find out later that for all the courses where you actually need to do something with data, you have no clue what to do. This in a way is even worse. And the other thing is that, let's say on a weekly basis, the material itself is not so complicated. So, you know, for any given week, I think you should be able to follow what it is that I'm trying to say. The only thing is that after 6 weeks, everything starts to look alike. And it starts to be difficult to, you know, try to hang in there and still understand what it was and how it was different in week 5 from week 4 and so on. Okay, I know, obviously, that this is the part where, you know, I explain that this is a good idea, and you think, yeah, we'll see about that. And be my guest, we will. So this is just a suggestion, do it as you do. Okay. One run through the actual hours for the course. 5 study points, that's 140 hours. That's, let's say, if you subtract 20 hours of exam preparation, 8 weeks of 15 hours, of which 6 you could follow here on site. 4 hours lecture time, 2 hours where you do some work here. That still leaves 8, that's a full day, of you independent practice time. Which is also, let's say, suggestive of, okay, if you're not making these hours and don't get it, then it's basically also up to you. Because you need a little bit more time to practice. Okay, and then, after trying to scare you to death about that you have to make sure that you do all this, the most important part that I'd like to bring home here is that this is actually a fun thing to do. As soon as you know at least a little bit what it is that you need to do here, this is, first of all, this is valuable stuff. Anybody in the whole world can read a book. Not everybody in the whole world can read a big bunch of data. Okay, so in the end, when you can, this is a nice thing to have, and also actually a fun thing to do. Trying to plow around in the data and making sure what's going on there. It's a good thing. Or, if you think, yeah, I don't like it so much, roughly for, let's say, work like this, where you do something with data, this will net you about, let's say, $100 an hour. If you look around on the internet for, let's say, data science, small work, so to speak, this will net you a serious amount of money. So if you're not in this for the intrinsic reasons that you like all this and these kind of things, but are, let's say, a little bit more sensitive to the monetary arguments, then still it might be a reason to pay attention and do some actual work. And finally, the one reason that I've left why you might like to do this is that apparently for something else. Who knows? This is apparently one of the hottest jobs there is. I'm not sure what hot means, that you get hired very easily or in a different sense, but who knows? It can't hurt. Being a nerd is a good thing again. Okay, one example of the kind of things you can do with data. There's typically also, let's say, why I am into these kind of things. First of all, this simply means that you can disentangle the ones who just talk and think that they know what they're talking about from the ones who really know what they're talking about. In this book, this is just an example of Soccernomics. Lots and lots of data about soccer games are being analyzed, showing, for instance, well, let's take the first one here, I don't want to go through all of them, but salary predicts performance very well. So one thing, one typical question on a standard soccer night might be, these guys earn so much money, and how reasonable is it to expect that the ones who earn more money are indeed playing in the team that then in the end will win more? Well, that certainly turns out to be a very decent predictor. Here you'll see R squared. As we will learn later, R squared will range from 0, when it is a very poor model, to 1, when it's perfect. And with 0.92, this is really, really close to, well, almost a perfect prediction of how good a team is going to do. So indeed, there is benefit in knowing what the players in a team earn to try to predict how well they are doing. And, by the way, if you think that the transfer sums work as well, they typically don't. So their standard wage per year, that'll work. If you look at the transfer sums that they get, or the clubs get, that certainly doesn't work. And let's see. Yeah, a couple of other things that you need to show. For instance, stars of recent World Cups or European Championships are typically overvalued. So if you happen to have, let's say, a lucky tournament, and you did quite decently in 4 or 5 games, then in all likelihood you get a transfer to a better club for a decent amount of money. But also in all likelihood, somebody has paid way too much for you. You can simply run the numbers, check if this is right, and it is. So in principle, then you're done. Then the next part is, of course, convincing the one without the numbers that you're right, and this is still a complicated thing. But still, you know. And what else? Yeah, it seems to be that the Dutch are typically overvalued, so we have had quite a few transfers apparently where a lot of money was at stake, and in the end that didn't bring home anything. And we see also something interesting that this year, the last one, the centre forwards versus the goalkeepers. Centre forwards are overpaid. You typically have the idea, because they are the ones who tend to score, of course, that they are the ones who should get the most money. Turns out to be not the case. And in fact, goalkeepers, who are usually not paid very, I mean, they are paid quite decently, but comparatively speaking, not paid so well, should actually get way more money than they do. Okay, let's take a 15-minute break, and then we'll continue. You close the laptops in there in the back. Okay, so we went through all the stuff that you need to do. We'll experience that later. I gave one example of the soccer data where we can show, okay, with the kind of stuff that we will learn here, you should be able to do these kind of things. And just as one example where you could actually see it happening as well is in this movie, Moneyball, another sport, baseball, where in fact, way before soccer came even close to actual data, they started to figure out, okay, might be a better idea than just to look at somebody swing a bat a couple of times, and then hoping that this person will do very well, perhaps keep track of what they're actually doing, and then in the end decide if we're going to buy or not. And in the movie here you can see what happened for the first time when they tried to do this in actual baseball. Brad Pitt in the lead role. And in fact, as you also see in the movie, the Brad Pitt character, in fact, in the end, you know, he came up with the whole idea, but it didn't turn out to be that he personally benefited so much from all that. But at least baseball itself has never been the same, because since then many other teams have used the same approach. Let's crunch the numbers instead of trying to look at somebody, hoping that you understand who's the good one and who's the bad one. Okay, I have a wordle here of the stuff that we're going to do. So the typical things that you're going to hear is analysis of variance or ANOVA, and hypothesis testing, and t-tests, and multiple regression, and what have you. H0 for the baseline hypothesis, all terms that in part you may have been familiar with already, and that will go through in more detail over here. Okay, then to try to make sure that we are making sense in terms of the three methods courses that we are going to do. This is what a general paper would look like. Give or take a few minor things, but this is normally what standard paper follows. First, there is a problem right in the beginning. Okay, what is this about? Why is this an interesting problem? For that, you need to know what interesting questions are. Descriptive questions, explanatory questions, all kinds of questions you might have, and how to formulate them. So we try to cover that at least a little bit in the first methods course. And the second part would be, well, we would try to think about who else has thought about this problem already. Usually, quite a few people have, and they have, in all likelihood, part of the solution there. And you could try to think about if you have a better idea about what the actual solution is, or how what you are going to analyze is actually a little bit smarter than what they did, or an extension of what they did. So thinking about what the solution might be, that's step number 2. Then you can think about, okay, if I want to analyze something, how am I going to do this? An experiment, a survey, a bunch of interviews, archival data, what? Each and every one of these different methods have their pros and cons. You need to know a little bit what they are. For here, I think 2 of them, the experiment and the survey, or perhaps the archival study, to get data that happens to be there, are typically what we're involved with here. Then, if you do the actual data collection yourself, if you run an experiment, then you typically do. If you run a survey, you also might, and the only case where you don't is when you get data handed over to you. That's also something that we want you to know something about. So throughout the rest of your study program, you'll have to collect data yourself in different cases as well. Here, we will focus much more on, okay, given that we have the data already, what can we do with it? But in principle, these we're trying to cover throughout your program as well. One part that we didn't look so much at, there is a little bit of technical stuff about sampling. How large a sample should you have? There is a little bit what Stata can help you with, and where you need to understand how that works. So that is something that we'll do. And the rest, or pretty much, all of the rest is, let's say, analysis of results, divided in 2 parts. First, a measurement part. Could very well be that there is stuff in your data set that is not a measurement yet, but that you want to promote to an actual measurement. And then the bulk of what we're going to do is actually related to relational claims. I think that there is a predictor variable x, and that x is related to y, something else that we want to predict. And for those, the larger part of the work is in trying to figure out how we can understand if there really is a relation between x and y. And that's what we're going to do. Okay, then, just to make that as clear as possible, as I said, normally data looks like an actual spreadsheet. Sometimes the data doesn't look like that, but you have to make sure that you get it in that format. And then typically the rows are different cases in your data, and the columns represent variables or characteristics of the data itself. So in this case, the example is I have a couple persons in the data here. Every row is representing a person, and behind it you see characteristics, in this case, of that person. In principle, there is nothing against doing it exactly in the transposed way. We typically never do. So you could have rows that are the variables and columns that are the cases, but we don't do it. So whenever you have data that is not in this format, you will have to somehow get it in a format like this. luckily for most of the stuff that we do here, you need not worry about this, and you get the data in the right format already. Okay, let's see. Yeah. So now we need to figure out, okay, if this is the stuff that we're after, the relation between x and y, there is an x and we're trying to predict y. What is it that we need to know before we can actually run our analysis in Stata or wherever? And for that, we need to think about what kinds of variables that we want to look at here. And there are a couple different kinds of variables. I'm going to skip this one for now. These are three that you should have had before. And the most important ones are the one on the top and the one over there. So one variable type is something that's called categorical or nominal. That's something that has two or more categories without an intrinsic ordering in it. So if the category would be which kind of movie do you like the most, and you know, action movie, a drama, a documentary, a comedy, who knows what. You could have, let's say, 10 different categories. These categories have no specific order in them. It's called a categorical or a nominal variable. And if they have two categories, these variables, they're also called dummy variables. So if you have something where there are only two obvious categories, for instance, male, female, this is typically what's called a dummy variable. Or something like, yeah, the example here would be, are you over 40 or not? Well, as yes or no. So that too is a dummy variable. That will be important because the things that we're going to do with data later on are slightly different depending on whether or not the variable is categorical with more than two categories, categorical with two categories, or, and that's actually the other one that is most important in this case, a variable is called interval. An interval variable is basically anything that you can measure, let's say, as a number, where the space in between the numbers has a well-defined property and is the same across the whole scale. So this is, for instance, why age would be interval. Okay, age, if that is, let's say, measured in years, then I understand that really the difference between 13 and 14 is 1 year. I know what that means, and it's also exactly the same as the difference between 27 and 28. And it has the same kind of meaning. That I need for a variable to be interval. Same goes for income. The difference between 1,000 and 2,000, I know what that is, I know what it means, and it's exactly the same as the difference between 4 and 5. If you don't have that, it's not an interval scaled variable. Something in between we have as well. We won't be using that so much, but if you have a question where there's an intrinsic ordering, let's say, what could you have here? Never, sometimes, often, always. Do you travel to the university through public transportation? And you could answer, well, never, sometimes, often, always. And here this is typically non-interval, because the same argument that I could try to make for interval, that doesn't work now. The difference between never and sometimes, first of all, it's not so obvious how often that is. So that's not obvious what that difference is. It's already a problem. And also it's not clear that the difference between never and sometimes is equal sized than the difference between, let's say, often and always. Everybody could have different ideas about that. If you have that, it's not an interval variable, and it's called ordinal, because we do know that never is less often than sometimes is less often than often, and often is less often than always. Okay, so a couple of these examples are quite straightforward. You will find that every once in a while there are variables that are not that easy to classify, perhaps not completely interval, but somewhere in between. But the main thing to get from this is that these two, categorical, with two or more categories, and interval, that's the stuff that you need to be able to recognize. And depending on that, there is a statistical procedure you should follow, and that's the stuff that we need to know. Okay, a couple of examples. Well, first an easy one. Let's say that the x variable over there is length, and the y variable over there is weight. Length is typically interval. It's well defined. We know exactly what it is. Weight is typically interval as well. So that would be a specific procedure that we need here that goes with two interval variables. An interval variable predicting another interval variable. Something else being female, and then being, let's say, more sensitive to alcohol. Let's suppose that you can measure sensitivity to alcohol in some way. For instance, how many glasses of beer it takes before you topple over. That would be a measure of how well you can take the alcohol. And being a woman is a categorical variable, 2 categories. And we can see if this is actually the case. So for this you need a procedure where your x is a dummy variable and your y is interval. And in this case, in fact, this is actually true, right? So we know from research that females are, in fact, more sensitive to alcohol. If you're interested in the details of that, you could read a book that's called Buzz, B-U-Z-Z, and there in all glorious detail is explained what exactly the reason is for that. It's not because females are shorter, it's also not because they have higher density or who knows what. There are other reasons for that, and if you're interested, have a look at the book. Something else then, if you listen to Mozart, there it's not obvious just yet. Is that measured in minutes per day, or is it measured as yes or no? That totally makes a difference. If you measure it as yes or no, it's binary. If you measure it in minutes per day, then it's interval. And then you could check if you score higher on an IQ test. And I give this as an example because 30 years ago or so, there was some research suggesting that if you have, for instance, toddlers listen to Mozart, that then they will in the end score higher on IQ tests. It turned out to be not true in the end, but there was a time when at least some people thought that that would actually be the case. 2 other examples that I mentioned before. You remember your angry memory versus you remember a control, you remember nothing. That's a dummy variable, so it's angry or not. And the y thing you want to predict here is the heartbeat. Heartbeat is again interval, well defined. Difference between 86 beats per minute and 87 is obvious, and it's the same as between 53 and 54. And another one from the Netflix example would be that, okay, if you're younger, then you like action movies better. Again, they're the thing you want to predict here is interval, and being how old you are is also interval. You may have noticed that all the stuff on the right here is interval scaled. So for all the things that we're going to try to predict, almost all, the thing that we are predicting is supposed to be interval scaled. So if we want to predict, are you going to be a millionaire, yes or no, this is not something that we'll use here because it's predicting something binary, and we are not going to do that. Then, terminology. In lots and lots of different books and screencasts and YouTube videos and who knows what, you'll hear different terms for these x and y things, and they're all the same. So we have dependent variable, response variable, target variable, y variable, or explanandum for the ones who are into Latin. All that means the thing that you want to predict, the stuff that is on, in this case, on the right side. Something is leading to the explanandum, the dependent variable, or the target. And the stuff on the other side, from which the arrow is coming, that's called the independent variable, the x, the predictor variable, or the, again, the Latin explanans. All that is pretty much the same and can be used through each other, and it's good that you know that it's there and that in principle all that is basically the same thing. Very often, especially for experiments, you want to be able to say something of the kind, okay, x is actually causing y, but very often for the data that we have, the best that we can do in the end is, okay, x is related to y. We don't really know that x is doing it, but we do know that there is a relation of the kind, okay, if x is going up, then y is going down, or the other way around. Okay, we have that in our data as well, and that in the different kinds of variables. I created the survey in such a way that there are different kinds of variables in the data that we can work with. And if you look at a couple of these examples, this is the data from a previous year, not from you. Here you see, for instance, let's see if you have male-female there, it's categorical. And then here you already have sort of a problematic variable. Do you want to call this interval scaled? Here it says, would you consider yourself to be better than the average student in your class? And there is an order in that, okay, far below, a little bit below, about average, a bit above, and totally above. So there is certainly order in there, but the differences are not well defined. So I'll treat this as a categorical as well. Here we can see is this distribution that we see over there across the different sorts of average. We see if I can. Yeah, not all at the same time. See everybody squinting at the actual percentages. So this distribution is that different for boys than it is for girls. That would need what's called a chi-square test, and it's one of the first tests that we'll go through to make sure that everybody knows how it works. Something else, there was an estimate for everybody. What do you think you're going to earn when you're 35? If that's the thing you want to predict, that's the target variable. You can compare it with two groups. Boys and girls, for instance, do females think that they are going to earn more than males? That would be binary, male-female, versus interval. Needs a different test. The test is called a t-test. That's the second one we'll do. We have, of course, age. There's not a lot of variation in age in this group compared to, let's say, a real population, but still, we could see the ones who are closer to 35 already. Do they think that they are going to earn more, or do they think that they are going to earn less? Age is interval. What you're going to earn is interval. We need something else here. It's called correlation or linear regression. It's actually the same thing. And something that I didn't discuss just yet. We also have different kinds of things in the data, basically meant to not so much to do something relational, but to measure something a little bit better. Here you see a long list of things of the kind. For instance, I don't feel particularly pleased with the way I am. I feel that life is rewarding. I find most things amusing, and a couple more of these statements. And this is typically done when what we want to do is measure something where you feel that it cannot be measured very well with a single question. So age is relatively easy. So I want to know your age in years. I ask, how old are you? You give me a number, and fine. If I want to get an estimate of how happy you generally are, then perhaps a better idea would be ask a bunch of questions, average those questions out, and that measurement will be better. Again, there's a procedure for that called Kronbach's alpha or scale analysis, and later factor analysis. We'll do that too. Okay, and finally, if we're interested so much in trying to predict what you think you're going to earn, then perhaps we could try to do this with all the data that we have. If you're male or female, how old are you? If you're going to the university by bike nowadays, perhaps you're typically the one who thinks you're not going to earn very much. If you are now really happy, perhaps you're in general more optimistic. All these kind of things you could try to estimate all at once in the data. Try to figure out if that works. That's called regression analysis. We'll do that too. And in principle, that's if you say it like this, it doesn't sound like much perhaps, but it takes a while before you get used to these kind of things and how it works. So we're going to go through the whole set of combinations of different variables, trying to predict a target from some inputs. Okay, one thing that is different from the actual data that you need to realize, because quite a few of these statistical procedures are slightly different from... Excuse me, the girls in the back there. No! I mean you. I waited a minute, another minute, and you kept talking. Now it starts to be annoying. Okay. Experiment versus survey. The tough part here is not the statistics. The tough part here is different kinds of statistical procedures were developed by different kinds of people, by the experimental people and by the survey kind of people. And that means that in the end, in statistical software, there is stuff there that is basically the same thing, but you find it in two places in the software. And that is totally weird. You might have expected that by now somebody took the trouble to sort of put it together and make one decent command of it. That's not the case. So we will encounter a couple of cases where we see, okay, this and that is totally the same, but it finds its way in Stata in two places, in SPSS, same thing, and that is sort of annoying, because there are several useful things that you can do here, where you would think, it would be nice if I could do that there as well, but it's not possible any other way. So you have to understand where these things come from. And where these things come from, exactly from the difference between what an experiment is and a survey. And here you see a picture from the well-known Milgram experiment, where we put people in a room. Who has never heard of that Milgram experiment? Oh, okay. You put people in a room, this is an actual subject here. You put them behind a machine like that and you tell them, okay, there's another person in a room over there. They are answering quiz questions, and whenever they answer not correct, you push a button over there, and the person in the other room gets an electric shock. And you hear it also. On the machine here are buttons, where buttons more to the right represent higher voltages. So after the first mistake, okay, now you give the small voltage, and you're out. And then again, somebody gets the second quiz question wrong, a higher voltage. You give the voltage, and you hear something again. The mistakes keep continuing, and the marks over there go way past gauges. Sometimes it's actually on the machine, sometimes it should be more or less obvious, because this is going, I think, all the way to 600 volts or so, which is certainly really, really dangerous. The whole setup is a hoax. There is somebody in another room, but this is somebody who belongs to the experiment, so there are no real electric shocks. The whole experiment was meant to try to see how far people are willing to go, sitting over there, administering the electric shocks, even when people in the other room beg to stop because they feel that they're going to die. Okay, so that was the part of the experiment that sort of made it to the world, where the interesting finding was that quite a few people here are apparently willing, given that they feel that they are in an experiment, to keep giving higher and higher electric shocks, even way above the dangerous levels. Okay, so that would be one way to look at the experiment. I simply look at what they do, I measure how far people are willing to go until they say, okay, I'm going to stop here, I'm not going to do this anymore, and I average out that number. And if you then find, okay, the average number in the whole group there is 485 volts, okay, this is sort of worrying because, you know, people would die. Okay, so that's one way to look at these data. And there are different ways to deal with these data. One kind would be in an experimental way, and another kind would be in a survey kind of way. Okay, now first, what could be, let's say, an experimental variable here? If you want to run an experiment within this setup, what could we do? Anybody who knows the original could come up with one. Yeah?
Professor there giving pressure on the subject that he needs to go on.
Yeah, so one way to go on with this experiment would be, in one case, you simply have the interaction with the person in the other room, and that's it, and at some point, if you want to stop, yeah, okay, then you stop. And the other thing could be, you have somebody there, you mentioned now professor, but let's say in a white lab coat, sort of looking official, and then if somebody says, yeah, I don't want to continue here, then the person in the white lab coat will simply say, please continue, this is an experiment. And then we see if that makes a difference. So we have something that we put in there, a person with a white lab coat, and we try to figure out if that makes an actual difference. And the other ways in which we could make an experiment of this that might influence the results here. Yeah?
Differentiating whether you have men or women at the machine?
Yes. Why do you think that would make a difference?
I don't think it would make a difference, but they did it in this experiment.
Yeah, sure. Okay. Now, the complicated thing that I'm trying to get across is exactly showing up here, because that suggestion is an experiment, and yours actually isn't. Why not? Any clue? You happen to know? Yes?
There's no control group, maybe?
Yes, sort of. Close. Go on a little bit. No?
You're not actively influencing the experiment.
Yeah, the manipulation, yes. So that was an experiment because you put the person in the white lab coat there. We have, let's say, half of the whole setup. We don't have somebody in the lab coat. The other half, we do have somebody in the lab coat. So we are sort of creating our own X variable. The variable is, there was a guy in a lab coat there. And for half of the cases, this gets a 1, and for the other half, this gets a 0. For the boy-girl, even there you could try to make sure that we have at least enough boys and girls so that we can measure an actual difference. But, you know, you're not influencing if somebody is a boy or a girl. So if the predictor variable there is, this is a girl, 1 for yes, 0 for no, then that thing is measured not manipulate. And that's the crucial difference between an experiment and a survey. Yes?
But couldn't you pick them out?
Go ahead.
Couldn't you pick them out of those boards?
Yeah, sure. You could, of course, try to make sure that, for instance, we have half of each. But what you cannot do, and that would cause that, let's say, half of the cases in your data would be ones, and the other half would be zeros. But it doesn't influence, let's say, whether or not there is a 1 or a 0 in the data. Yeah.
Seeing one receiving the shots or not seeing the person?
Yeah, that would be another, it would be an experiment. So one idea would be people would respond differently if you actually see the person suffering. Now you only heard the person suffering, you didn't see that person. But if you see somebody there who's actually going to his knees and almost dying, and perhaps you're more willing to stop earlier. Another one would be, by the way, I have this sticker over there, over here, versus not having a sticker at all, making it totally obvious that this is really, really dangerous. You can imagine that this is also a difference. Again, something that you manipulate, you put the sticker there for half of the cases, and you don't put the sticker there or in another place for the other half. This is an experiment. If it's something that's measured, this is a survey. Let's see if I have... So if somebody's male, or how old is that person, they're all measured predictor variables, survey-like data. And the other one that I had here was a danger sticker. The subject is given a sweater to wear. I do not see any reason why that would make a difference, but it's something that you could influence at least if you feel that there is a need to it. And the experimenter wears a white lab coat. We had that already. Okay. That, in fact, is the thing you need to be able to distinguish. Experimental data only exists if you have predictor variables that are under the control and being manipulated by the research. If you don't have this, if you run a survey, tell me about this, tell me about that, tell me about this, tell me about that, that's not an experiment, because none of the things that you measure are under your own control. Okay, so, one way to also say that would be like this. An experiment is you manipulate your X, and the survey is you measure your X. You just happen to have an X lying around, and that's typically it. Okay, next part. Moving on to the data and the data interface. First, what you need to be doing in the end, as soon as you get data. This is your standard data run for any kind of thing you want to do. You import your data file, obviously, so you double-click on your data file and data will open. That's the easy part. Then, what you need to get acquainted to is checking your data, simply to triple check if all the data that's in there is making sense. There are mistakes in data all the time, and you have to make sure that you find them. And this is also why at the exam, you'll get some data, and I will make sure that there are mistakes in the data, just to make sure that you will check. Okay, so I'll tell you up front, and I'll tell you again, in the data that you'll get, you'll find mistakes, and you have to check for it. Then, given that you know what kind of data you have, and what kind of predictor variables and target variables you have to know which kind of analysis to use, that we're trying to solve in the next couple of weeks. Then it might very well be that from the data that you have, you want to create a couple more variables. For instance, you have age, and for some reason I want to have age squared, or something else. I have age measured in years, but I want age simply measured as over 65 or not. That creates extra variables in my data. So I start with something that is the raw data as I get them, I check them, and now I create, if I need it, a couple more extra variables. Then what you want to do very often has assumptions. You can only run a test if. Okay, you have to check the assumptions. You run your analysis, and for some of the assumptions, we will see that, strangely enough, we can only test the actual assumptions after we do it, which is sort of weird. So it might be that you need to run a t-test first, and then afterwards check, okay, was it actually okay to do that at all? And then find, no, it wasn't. And then the whole thing that you did up to then is of no use anymore. And that you repeat that, okay, back to the data, check my assumption again, run the analysis until you're done. Until you think, okay, now I have an answer to the actual question, and that's pretty much it. This is the standard run through data that you're supposed to get used to. Okay, a little bit of Stata stuff. Let's see. Okay, this is what the interface of Stata looks like. In principle, nothing special. Here on the left, you'll have the variables. I have now the interface set up in such a way that here there is another tab that will show previously entered commands. I never use this. Here you get the output from Stata as soon as you tell it to output something. And here you can type in commands immediately if you want to. Here, let's see, where we have that. We have a whole graphical user interface that I'm not going to use. It's useful every once in a while if you know where the commands are, just to double check what was the command again. But in principle, none of that I'm going to use. What I'll try to do now is take you through a run of an actual do file, briefly showing the basic stuff that you can do here. This is the do file editor. I prepared a little bit here. Normally you would get the do file to open if you click over there. There's an actual button there. And the first thing to note is that, well, first of all, there's a lot of stuff in green. All the stuff in green is commenting. And you get comments in two kinds of ways: by putting a star right in front of the actual stuff that you're going to write, or by typing a double slash. All the stuff after a double slash is disregarded. The difference is that a star you can only put at the beginning of a line for it to work, and the double slashes you can add halfway as well. So for instance, here below, these are a couple of Stata commands on the left. Here I have two slashes, and all this is commenting. So none of that is doing anything in Stata. If I would have typed a star here, it wouldn't have worked. Okay, so that's... yeah, if you want, you can save a log file. I do this rarely, but for now we can skip this. Typically, all the output will run in the output window. And then the only thing that you need to realize, not for this example, but in general, it's a good idea to put in a single folder the data file that you're going to do something on, and the do file that you're going to create to execute the commands. So that they are together in one place, and then you have to tell Stata where that is. And that needs something like this, either through the windowed interface, file, change working directory, and then you can try to find a directory where all the stuff is. And if you do this, then you'll see that you get output here that actually gives you the command. All relatively straightforward stuff. But for now we don't need this because I'm going to use one of the example data sets from Stata itself. Okay, so all this is commenting, nothing has happened up to this point. I start with the command clear, get rid of all the stuff that I might have in Stata. And here I start reading in Stata's system dataset. And because it's a system dataset, I have to start with a command that's called sysuse. The normal command would be use if it's a dataset. And auto is auto not from automatic, but auto from cars. This is an example dataset with actual cars. And if I type here a command, for instance, X, that is not a real Stata command, you simply carry out this whole thing using this play button over there. It will start from top to bottom. It will run this command, that command, the summarize command, and will stop at the X because it doesn't recognize what an X is. If you want to be a bit more neat about this, you can type exit. Then it will exit without an error message if you feel better about that. Okay, so here we have it. All the stuff that happened is in the output, including all the comments. And what you'll see here is an overview of the actual data, where you see on the left all the variables. You also see now that in the variable window, all the variables are actually mentioned. And you see a couple things for every variable, how many cases we have. 74 have a price value. The mean price is a little bit more than 6,000. These are cars from somewhere in the 70s in the United States, I think. The standard deviation of that variable, the minimum price and the maximum price. Okay, and all these different kinds of data you see for each and every variable in the data. You see, for instance, here that rep78, which is the repair record for an actual car, has only 69 observations, so there must be at least 5 missings. Something else that's sort of weird is that this one seems to have no observations, which is a bit of a weird thing from Stata, because it does have observations. It simply shows here that this make variable is a string instead of a number. And I can show you what the data looks like by either clicking somewhere over there or typing browse. And then you'll see something, oh, it's really small now, but you see something that is, let's say, spreadsheet-like. This is the spreadsheet that is there behind the scenes. In the column labeled make, you see, first of all, you see stuff in red instead of in black, suggesting that these are all string variables. So this is an AMC Concorde, this is a Buick Regal, and a Chevrolet Chevette, and so on. So this doesn't mean that you have a 0 there, that there is no data. It simply means that it is text-based. And some more info here, and we can close that again. Okay, let's look at a couple of standard commands here. Summarize would work and would give you an overview. If you have a large data set, it might be a good idea not to have a summary of all the variables in the data, but just the one that you're interested in. Then simply type the actual variable name behind it, summarize price, you get only price. And you get some more stuff as well. If you want more detail, you could add an option to a command, and this is also standard Stata in the sense that options to commands typically are written like this. You add a comma at the end, and you add the actual option behind it. In this case, it's called detail. What will happen is this. You'll get the output. This was the summarize command. This was the actual price. And this is summarize price, and then give me some detail, and it gives you a little bit more. For instance, different percentiles for that same variable. Let's see, what else do we have? We also see skewness and kurtosis. I don't think we went through that, but we will later on. So this is a little bit more information than what you had before. Another one that's useful is a command that's called tab. Show me all the values of a given variable. So in this case, tabulate the variable is called rep78. And I'll immediately run the same thing, but now I add missing. And let's see what that does. This will give you an overview of all the values that I have for this variable in the data. And it is apparently 1, 2, 3, 4, and 5. There are 2 cases with 1, 8 cases with 2, and so on. And in total, this is 69 cases, including the percentages and the cumulative percentages. But we know from the data that there are more cases in there than 69. Actually, there were 74. And I do not see any missings here. And if you want to see the actual missings, you have to ask for it through this one. Same command, now with an option miss for missing. And now the missings that you have in the data are in there as well. And you might think that, a couple of missings, I don't care about this. But this will be a major pain in the neck if we have data that are a bit bigger than that. With, let's say, 20 predictor variables, each of which has a couple of missings. If then it turns out that we do not have a single case where all the cases are actually there, then we're in trouble and cannot run anything anymore. Okay, almost done. If you would like that in a single command, why do we need to type this twice? Well, there are people somewhere who have made a command that actually does that, and that goes for many other commands as well. These, if you want to access them, you have to install, well, in different kinds of ways actually, but here, net install and then FRE for frequency would actually do it, would give you a new command that's slightly different. Let's see what it does. Where you now have in a single table both the missings and the 1, 2, 3, 4, 5 that you do have, and the 74 that you have in total. So in a way, this is actually the better command. And the thing to do would be make sure that you install that frequency command once, then you'll have it. As soon as you have it, you never have to install this again. Okay, final thing that I'd like to look at is this part. You have if statements and and statements. So if I want to have a summary of price only in those cases where, let's say, the variable foreign is equal to 0, the main thing to get to grips with here is something like this. If foreign equal to 0, you might expect a single equal sign, but you have a double equal sign. This is standard Stata lingo for is in value equal to 0. In fact,
foreign equals 0, which is the single equality, Stata could interpret this as that the variable foreign is 0 for each and every case that you have. So it's a long list of zeros, but that's not what you mean. You mean only for the cases where foreign is equal to 0, summarize the price variable. This is why you need the double equal sign. And there's a couple more stuff that you can go through by yourself. We have if statements where you can include ands and ors, all pretty regular stuff. You can go through these all by yourself and have a look at how that works. In fact, the first module is make sure that you get Stata installed and get comfortable with the actual interface. Okay, back to PowerPoint. Okay, so this is what these do files look like. We went through that already, and you should use them every time. And I know from experience that people tend to forget this and start typing interactively and running parts of code one after the other. This is going to be a mess really, really, really fast. So get acquainted to, as I just did it, make a do file, run it from top to bottom every time. That's the only way to make sure that it will run the next time as well. Okay, so data stuff, canvas, we did that. Stata, should start to install it, all related to X's and Y's. And when you're done, you basically know your way in a startup sense around data. Now, what there is to do, first you need to check if you can go into the canvas site, and even the ones that do this for 0HPH something should be able to access the site now. Update your personal info if need be. That should all be correct, but double check. And the rest that you're supposed to do for today is download and install Stata, get acquainted with Stata and Stata do files, and go through the assignments that you have there. And the last thing is, if you haven't completed the survey just yet, please make sure that you do it by today so that we can work with the data on Friday.